Okay, guys, Timmy coming at you today. And today we're going to go over the hormones. And specifically, what I'd like to do is go over the specific hormones of the pituitary gland. Now, the pituitary gland is kind of unique. It's referred to as the master gland, or I like to call it gland master P. Get it? Gland master P. And the pituitary gland is divided into two lobes. There is an anterior lobe, and then there's a posterior lobe. The posterior lobe releases two hormones under the effects of the hypothalamus. So the hypothalamus actually produces these two hormones, and then they're actually released by the posterior gland of the pituitary gland. So the hypothalamus produces ADH, and it produces oxytocin. So again, hypothalamus, neural, pituitary, glandular. So how you remember this is it's called goat flap. Real simple. So G, growth hormone; O, oxytocin; A, ADH; T, thyroid stimulating hormone; the flap, follicle stimulating hormone, luteinizing hormone; ACTH, and prolactin. And the two hormones, again, that are released from the posterior lobe are oxytocin and ADH. The rest are released from the anterior lobe. So let's do a couple of things first. Number one, the hormones that are released by the pituitary gland, a lot of them, especially the anterior ones, have effects on other glands of the body to release their hormone. So an example would be ACTH. It stimulates the adrenal cortex to release three primary hormones. That is aldosterone, DHEA, which is the mother of all hormones, and that tends to be converted to testosterone. And cortisol. TSH, released from the anterior lobe, and thyroid stimulating hormone will stimulate the cells of the thyroid gland, and the hormones that the thyroid gland release is T4 or thyroxine. I'll go into more detail in a little bit. Follicle stimulating hormone, luteinizing hormone are released in response to reproductive things. For example, follicle stimulating hormone in women that helps mature an egg, a follicle. Luteinizing hormone tells you to release the egg to ovulate. Prolactin tells you to begin to produce and let down milk. So once the kid pops out, you're ready to feed him. Growth hormone, as the hormone implies, right? It makes you grow and increases protein synthesis all over the body. So let's do this first. Let's start out with ACTH. Now this is important. If you recall, cortisol is your chronic stress hormone. So like being in nursing school or in my class, there are there's several stress hormones, but the big ones are cortisol and epi. And I'm going to try and simplify this for you as much as I can. This is acute stress. You think the Hamburglar's at your door. The sympathetic nervous system is stimulated, and then the adrenal cortex, the inner portion of the adrenal gland, releases epinephrine. And epinephrine serves basically one purpose, and it's an important purpose. It is to prepare your body to run or fight. I, of course, prefer to run because at my age, I could get hurt. Cortisol, on the other hand, is chronic stress, long-term stress, like this class. So let's talk about that. So where do you perceive stress? Well, you perceive it in your brain. And the hypothalamus is then going to stimulate the anterior pituitary gland to release into the blood the hormone Acth. That stands for adrenal corticotrophic hormone. What that does is that circulates in the blood. And where are your adrenal glands? They're sitting on top of your kidney. And, of course, your two curved lines in a circle. You have ACTH receptors on the cells that make up the adrenal cortex. So we'll just call this the adrenal cortex cells. And when ACTH binds to that receptor, it's going to cause the release of cortisol into the blood. Now, there are basically, I'm going to simplify this even more. It's a little more complicated, but not much more. There's two types of hormones. There are peptide hormones. That means they're mostly proteins, amino acids chemically bonded together. And then you have hormones that have cholesterol as a base. And the hormones that have a cholesterol as a base are steroid hormones. Cortisol is a steroid hormone. So, what caused the release of cortisol from the cells of the adrenal cortex? Well, ACTH. Why did you get ACTH released? Because you've been chronically stressed. Cortisol does two things. Number one, its job is to raise your blood sugar. I'll be a little more specific later. The other is it's your body's most powerful anti-inflammatory. So, when do people get cortisone derivatives? They'll get prednisone. Why? Because they have inflammation. You can get steroids when you have asthma or chronic bronchitis, both of which are inflammatory processes. And what produces inflammation? The immune system produces inflammation. So cortisol suppresses the immune system. The immune system's function is to produce inflammation. That's how it protects you. But sometimes you get too much inflammation, and that is bad. So that's why you get the release of cortisol, or you start on drugs like prednisone. Okay, so how does cortisol elevate your blood sugar? Well, here we go. Again, two curved lines in a circle. Where do you store extra glucose? Store it in the liver. So when you have cortisol around, again, I'm simplifying, cortisol is going to bind to a receptor, and glycogen is glucose chemically bonded together, right? So what cortisol does is it binds to the receptor in the liver, and it causes the bonds that held glycogen to be together to be broken. What does that do? That frees up glucose. What up, G? And it will go into the blood. That elevates your blood sugar. So that's one thing it does. So one of the functions of cortisol is to increase glycogen breakdown to glucose. That's one. Number two. We all learned, and I know we did, that in order to get glucose from the blood into the cell, insulin is released when your blood sugar's high. So you got glucose in the blood, it's elevated because you ate some fruity pebbles, which by the way is really bad, nasty stuff, smells bad. In order for glucose to go from the blood into the cell, insulin has to bind with a functioning insulin receptor. And when insulin does that, it opens up these lovely little gates in your cell membrane and allows the glucose to diffuse from the blood into the cell to lower your blood sugar. When you got cortisol around, cortisol decreases the number and sensitivity of insulin receptors. So again, if insulin can't bind to those receptors, you can't lower your blood sugar. So the second function of cortisol is to decrease the number and sensitivity of insulin receptors. And that, ladies and gentlemen, ultimately, if you're on steroids long enough, a long dose of prednisone, you will get type 2 diabetes. So that's why many people who are on steroids long term end up taking metformin, because you're never going to believe this. Guess what metformin does? Metformin increases the number and sensitivity of insulin receptors. So that's why. Another thing, because doctors know this, and now you should know this,